to look at factoring by using the quadratic formula. So the quadratic formula is going to help you find the zeros, which are the same thing in the roots. So solutions, zeros, roots, x-intercept. These are all the same. So this is all the same meaning. So it says find the zeros of 2x squared plus 7x minus 3. And we're going to use a quadratic formula, which is x equals negative b plus or minus b squared minus 4ac. That's the square root of that divided by 2a. So it's very important that we are very meticulous and take our time with this. So a equals 2, b equals 7, c equals negative 3. A, b, c. So let's go ahead and build our quadratic equation. Quadratic formula. X equals negative b, which is 7, plus or minus the square root of 7 squared minus 4 times a, which is 2, times c, which is negative 3. All of this divided by 2 times a, which is 2. To simplify, what is underneath the square root stays underneath the square root. That's all going to be simplified on its own. And it's a lot of writing and rewriting. Negative 7 plus or minus the square root. We're solving underneath the square root. Order of operations. Exponents. 7 times 7 is 49. And then you're going to multiply negative 4 times 2 times negative 3. Negative 4 times 2 is negative 8. Negative 8 times negative 3 is positive 24. All of this divided by 2 times 2, which is 4. Keep on going. Negative 7 plus or minus the square root. 49 plus 24 is 73. All of this is still over 4. We're solving for x here. So now we need to see if there's anything, if there are any perfect squares underneath the square root of 73. 73 is a prime number, which means it can only be multiplied by 1 and 73. So now that brings us one step closer to solving for our solution, or solving for our zeros. Bring this over. And we're going to split this up with the plus and minus. So the first one is x equals negative 7 plus the square root of 73. All of this over 4. Or x equals the negative 7 minus the square root of 73, all of this over 4. Both of these are our solutions. Please do not give me decimals. Quadratic formula. X squared plus 2x minus 3. We're going to use a quadratic formula to factor this because it specifically states that we're just practicing the quadratic formula. Obviously this can be factored easily. If for some reason you feel that you can factor it using the tic-tac-toe method or the berry method or however it is that you factor, please do that. Other than that, let's go ahead and continue from here. So I'm going to say negative b plus or minus b squared minus 4 times a times c, the square root, all of this over 2a equals x. In this case, a equals 1, b equals 2, and c equals negative 3. So we're going to say, it doesn't matter what side the x is on. So x equals negative b, which is 2, plus or minus the square root of b squared, which is 2 squared, minus 4 times a, which is 1, times c, which is negative 3. All of this over 2 times a, which is 2 times 1. Simplify, negative 2 plus or minus the square root. We're going to simplify underneath the square root. PEMDAS 2 squared is 4. Negative 4 times negative 1. I'm sorry, negative 4 times 1 is negative 4. Negative 4 times negative 3 is 12. So it's positive 12 all over 2. So I'm going to keep on simplifying. Negative 2 plus or minus the square root. 4 plus 12 is 16 all over 2. Okay, now let's look at the square root of 16 on its own. So the square root of 16 equals 4. So when I rewrite my x, I'm going to rewrite it without the square root. So I'm going to say equals negative 2 plus or minus the square root of 16 is 4. All of this divided by 2. So now I can say x equals negative 2. I'm going to split up my solution into two different solutions. Plus 4 divided by 2, or x equals negative 2 minus 4 divided by 2. I'm going to simplify 2 plus 4. Negative 2 plus 4 is 2 over 2 equals 1. Or negative 2 minus 4 equals negative 6 over 2, which equals negative 3. X equals 1 or negative 3. X equals negative b. That's negative times a b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. 3x squared minus 10x plus 5. A equals 3, b equals negative 10, c equals 5. X equals negative 1 times b. b is negative 10. Plus or minus the square root of negative 10, which is b squared minus 4 times a times 3 times c, which is 5. All of this over 2 times a, which is 2 times 3. We're going to continue to simplify from the outside and then the square root. Negative times a negative is a positive, so I get positive 10 plus or minus. It's underneath the square root. Negative 10 squared is 100. Negative 4 times 3 is negative 12. Negative 12 times 5 is negative 60. 2 times 3 is 6. Keep on. 10 plus or minus the square root of 40 over 6. Now we're going to look at the perfect squares of 40. So 40, when I factor it, I want to factor out the perfect squares. So I get 4 and 10. perfect squares are 1 squared equals 1, 2 squared equals 4, 3 squared equals 9. So the opposite of a perfect square is a square root. So let's just say I put the square root over these. I want to write an equivalent statement. I'm now saying that, remember, look, we're looking at the square root of 40, that 10 plus or minus the square root of 40 is now going to be equivalent to the square root of 4 times the square root of 10. All of this over 6. So I'm going to simplify. I'm going to say 10 plus or minus. If I take the square root of 4, I get 2. I do not take the square root of 10, so I just leave it, and becomes 2 times the square root of 10. All this over 6. And there's something very specific here. We cannot do anything to the square root of 10, but we can do something to the 10, the 2, the 10, and the 6. All of these are factors of, or have a common factor of 2, so we're going to divide each of them by 2. So I'm going to get x equals 5 plus or minus the square root of 10 over 3. If I expand it, x equals 5 plus the square root of 10 over 3, or x equals 5 minus the square root of 10 over 3. These are my solutions. I would like to see it expanded and without decimals. Alright, see you in class.